Friends, welcome back to a new video. In the previous session we learned that how to find the integral of sin nx dx and the integral of cos nx dx. That is the power, that is nth power is here existing. So today we are learning about how to find when here 0 to pi by 2, that is here a limit is existing in both case 0 to pi by 2 in cos and in sine function. So how to find the solution for these formulas or these integration questions. So first we are talking about, in this session we are mainly talking about how to find the 0 to pi by 2 integral of 0 to pi by 2 sin nx dx. So let's check it out. So before starting this session, don't forget to subscribe our channel for more informational videos. So let's begin. We know the formula for what is integral of sin raised to nx dx is, which is equal to minus sin n minus 1x cos x divided by n plus n minus 1 divided by n into integral of sin raised to n minus 2x dx. So here we want to find that not integral sin raised to nx dx, that is here limit is existing, that is 0 to pi by 2 sin raised to nx dx, which is equal to, so put a limit here, that implies that minus sin raised to n minus 1x cos x divided by n with the limit 0 to pi by 2 and plus n minus 1 divided by n into integral 0 to pi by 2 sin raised to n minus 2x dx here. So note that here the first term it will be equal to 0 and plus n minus 1 divided by n into here 0 to pi by 2 sin raised to n minus 2x dx. Put it as I n minus 2 here. Then this one as implies that I n. Then we get I n, which is equal to n minus 1 divided by n into I n minus 2 here. So this is the formula for I n. So here I n minus 2 term is existing. Then find a solution for I n minus 2 again. That means that by taking I n minus 2, that is I n minus 2 here. I n minus 2 means that put n minus 2 value in the equation number this one. That is when n is equal to n minus 2, then there is a change in the full formula, that is equal to n minus 2 minus 1 divided by here denominator n minus 2 into I n minus, that is I into n, in the place of n we can put that n minus 2 minus 2. Then we get an answer as n minus 3 divided by n minus 2 into I n minus 4 here. So in the next step from the equation number 2, find the solution for I n minus 4. Likewise we can get a repeated chain here. So finally we can get different types of repeating formula here. Then finally we can put that formulas in the equation number 1, then which implies that or which equal to, so finally we get an answer like I n is equal to n minus 1 divided by n into here n minus 3 divided by n minus 2, which means that the value for I n minus 2, that is equal to n minus 3 divided by n minus 2 into I n minus 4. When putting this value here, then we get I n minus 4. After I n minus 4, which is equal to n minus 5 divided by n minus 4 into I n minus 5. Then the value for I n minus 5, which is equal to n minus 7 divided by n minus 6 into I n minus 6. Then the value for n minus 9 divided by n minus 8, which is equal to I n minus, then etc etc etc. Likewise this term is continuing. For this formula there is specified two result is existing, that is when n is equal to odd and n is equal to an even number. So here note that when n is equal to odd and n is equal to even, there is a different formula is existing for that both different cases. So before finding that formula for n is equal to even number and n is equal to odd number, there is a specific case is existing, there is a note is existing, that is when we taking n is equal to 0, 1, 2, 3 etc. in the equation first I n is equal to n minus 1 divided by n. So here we can easily find the value for when putting n is equal to 0, 1, 2, 3 etc. So let's check it out. When finding the solution for I0, which is equal to 0 minus 1 divided by 0 here, which is equal to minus 1 divided by 0 here, then which is equal to the value infinity, or it is not a determined form. When finding I1, which means that 1 minus 1 divided by 1 here, that is 0 divided by 1 here. that is equal to 0 into 1 by 1, which is equal to 0 here. When finding I2, which is equal to 2 minus 1 divided by 2, which is equal to 1 divided by 2, that is 1 by 2. And finding I3, I3 is equal to 3 minus 1 divided by 3, which is equal to 2 by 3. So here we get a value for when n is equal to 0, 1, 2, 3, then I is equal to, that is in is equal to, corresponding to 0 we get infinity, then corresponding to 1 we get 0, corresponding to 2 we get 1 by 2, and 3 2 by 3. Likewise it is continue after and after. Then from our equation in is equal to this one, when put n is equal to 0, then we get this first term as, and when putting n is equal to 1 here, then which means that 0, that is 0 which will be multiplied with the whole term, then which will be converted into a 0 value. So first we want to find a proper solution for this case, that is when n is equal to 0 and n is equal to 1. So note here that when n is equal to 1, then which implies 0. So by theoretical concept we can find a proper answer, that is not when n is equal to 1, then the whole term becomes 0, and 0 that is integral of 0 to pi by 2 sin raised to nx dx, which does not is equal to 0. But how? So let's check it out. When I1, which is equal to integral 0 to pi by 2 sin 1x dx, that is sin raised to the power 1x dx, which is equal to minus cos x, that is the integral of sin x, which is equal to minus cos x, with the limit 0 to pi by 2. Then applying this limit we can get 0 minus minus 1, which is equal to plus 1 here. Therefore in the case of odd, that is odd number, then n must does not is equal to what? 0, that is the value which is equal to 1. So we can get a proper answer for that one, that is equal to, this is not 0, this is 1 here, that is plus 1. Likewise when we finding that n is equal to 0, that is n is equal to 0 here, we can get a proper answer. But how? Let's check it out. That is when n is equal to 0, that is I0, which is equal to integral of 0 to pi by 2 sin raised to nx dx. Put n is equal to what? 0 here, then which means that 1 here, that is 0 to pi by 2 1x dx, sorry 1 dx, not 1x dx, no, 1 dx, then which is equal to, here only the x value is existing, that is x with the lower limit 0 and upper limit pi by 2, which is equal to pi by 2 minus 0, which is equal to pi by 2. That is the value for when n is equal to 0, then we get an answer pi by 2 here. Likewise we get a proper solution for when n is equal to 0 and n is equal to 1 here. So let's come back to the previous one, that is in is equal to a proper solution here. Then when in the case that is n is equal to odd, so here when finding I5, put n is equal to 5 here, that is 5 minus 1 divided by 5 into 5 minus 3 divided by 5 minus 2 into 5 minus 5 divided by 5 minus 4. So stop here and note that when 5 minus 1, that is equal to 4 divided by 5 into 5 minus 3, which is equal to 2 divided by 3 into 5 minus 5 divided by 5 minus 4 here. That is 5 minus 5, which is equal to what? 0 here, divided by 1. So note that the value for this one, which is equal to what? The answer is also 0. So there is no need to consider it, and we now when the value is 0, then which is equal to the value for what? I 1, then its value which is equal to for 1. Therefore these values implies that which is equal to 1 here. So the final answer will be is equal to 4 divided by 5 into 2 divided by 3 into 1 here. Then final solving this formula we can get a proper solution here. So finally we can define a proper solution for when n is equal to for all odd numbers. Then finding that in which is equal to for odd numbers, n is equal to odd number, then in which is equal to n minus 1 divided by n into n minus 3 divided by n minus 2 into n minus 5 divided by n minus 4 into etc. into finally there existing a 2 by 3 into I0. 2 by 3 into I0 in the last terms. That means that, note that here there is 2 by 3, then after 1. Here this 1 means that the I1, that is here I1. So not here I0, so here I1. So this is the formal formula for In where n is equal to n odd. So there is existing in similarly when n where n is equal to an even number, then which is equal to n minus 1 divided by n into n minus 3 divided by n minus 2 into n minus 5 divided by n minus 4 into etc. into 1 divided by 2 into final I0. So we know I1 is equal to 1 and I0 which is equal to pi by 2. So these are the formula for the solution where In which is equal to integral 0 to pi by 2 sine raised to nx dx. So here which is n is equal to an odd number and here n which is equal to an even number. So these are the formula for when n is equal to odd and n is equal to even, and we can simply find the solution. We find the formula for integral 0 to pi by 2 sine nx dx, where this formula we can only check that when a question is arising, we can only check that what is the value for n which is equal to odd or which is equal to even. So which is equal to odd, we can use this formula, that is the equation number 1, and which is equal to n is equal to an even number, we can use the second formula here. So note that in this video or in this session we are mainly learn that how to find the integral of 0 to pi by 2 sine raised to nx dx is, which is for n is odd number, then which implies that the formula that In is equal to n minus 1 divided by n into n minus 3 divided by n minus 2 into n minus 5 divided by n minus 4 into etc. into 2 by 3 into I1, where the value for I1 which is equal to 1. For n is equal to even number, the solution for integral of 0 to pi by 2 sine nx dx, for n is equal to an even number, then we can get a formula In is equal to n minus 1 divided by n into n minus 3 divided by n minus 2 into n minus 5 divided by n minus 4 into etc. into 1 by 2 into I0, where I0 which is equal to pi by 2. So in this next session we can look it out that how to use the specific formula for different questions were existing. So let's wind up this session here and see you soon in the next session. So stay tuned with us.